Hello children, today we are going to discuss the lesson light. First topic is rectilinear propagation of light. Children, what does it mean? It means that light travels in a straight line. We can prove it by simple experiment. We will take a tube and we will put the candle here, and when we see from this side, we are able to see the flame of the candle. But children, if we bend the tube, okay, are we able to see this? No. So this proves we are not able to see the flame of the candle. So this proves that the light travels in a straight line, and we call it rectilinear propagation of light. There are many experiments related to it. Now we are going to discuss reflection of light. What is reflection of light? Bouncing back of light is called reflection of light. What is this bouncing back? Children, when we throw ball on the wall, it comes back to us. So this is what bouncing back. Same manner, the ray of light bounces back when it strikes any surface. And you know children, we are able to see the object because the rays, when they reflect and they reach to our eyes, we are able to see the object. In dark room, we are not able to see our face in the mirror, but when we switch on the light, what happens? The light rays strike on us. After bouncing back from us, it reaches to the mirror, and after bouncing back from the mirror, it reaches to our eyes, and we are able to see the image. Just students, see what are laws of reflection. This is the ray which is falling on the mirror. We call this ray incident ray. Incident ray. Okay, we always one thing we do where the ray falls, we always draw normal, and this normal is 90 degree to the it, or we say perpendicular to the mirror. And children, this ray which fall on the mirror, after falling, it reflects back. This ray is called, this imaginary line is normal, and the reflected ray is called, this is what? Reflected ray. What is the relation between incident ray and reflected ray? The angle formed between normal and the incident ray is called angle of incidence. And between the normal and the reflected ray is called angle of reflection. Both angle of incidence and angle of reflection both are equal. So this is the law of reflection, first law, and second law is incident ray, normal, and reflected ray. All three they lie on the same plane. Now we are going to discuss what is the difference between real and virtual image. Real and virtual. Children, why are we studying this real and virtual? Because the mirrors, they form two types of images, real and virtual. What are the real images? The images form which we get on a screen. Okay, they are called real images, which we get on a screen. Like in movie hall, you see the movie like after reflection, what it comes on the screen. So the images which we get on screen, they are called real images, and real images, they are always inverted. Inverted means upside down. But by placing more lenses and all, we make it straight. That is why we are able to see straight image on the screen. Otherwise, it is always inverted, like in our eye, the retina is there, it works as a screen, and this is what? Lens. The image of any object forms on the retina is always what? Upside down. So it is formed on a screen. This is real image and inverted, and this is corrected by our optical nerves. They carry the message, and this is corrected by our brain, and we see the object at the same distance and of same size and erect. Now come to the virtual. Like you see your image in the mirror, this is what? Virtual. Virtual means it forms behind the mirror, and we cannot, it seems it forms behind the mirror. We cannot get it, cannot get on the screen. Okay. And this is always virtual. Virtual images, they are always, this is virtual, and virtual images are always erect. So this is the difference between real and virtual images. Now we are going to discuss the properties of image formed by plane mirror. Properties of image formed by plane mirror. All you have seen your image in the plane mirror. First is what? It is, we cannot get this image on the screen. That is why this is virtual. Second, it is erect. Third, it is of same size. Fourth, it forms at the same distance. The image forms, it seems to be formed at same distance. Like if we are keeping the candle, this is suppose mirror, if we are keeping the candle 5 centimeter away, we will see the image 5 centimeter behind the mirror. Okay, so same distance, and what is the distance between the object and the image? Around, it is 5 plus 5, 10 centimeter. Okay, so the image is formed at the same distance, and the most important is laterally inverted. What is the meaning of laterally inverted? The right of the object, it is the left of the image. So this inversion is called lateral inversion. So these are the property of the plane mirrors, image formed by plane mirrors. Now we are going to discuss the spherical mirrors. What are spherical mirrors? Curved mirrors are called spherical mirrors. It seems any hollow glass cut into two pieces. Okay, and this side we are going to paint from the outside, and we are going to get the mirror, and this mirror is called concave mirror. And this side, this part of the sphere, we are going to paint from the inner side, and outer side is worked as mirror. This is what? Convex mirror. Now, children, we are going to discuss the different part of these mirror. This center of the mirror is called pole. Pole, and we denote it with the P, and the line passing from the pole is called what? Principal axis. Okay. This line is what? Principal axis. Okay. And the center of this sphere is called center of curvature. Center of curvature. And children, next is like some parallel rays which are coming from the distance. What happened in concave mirror? These rays, after striking the mirror, they converge at certain angle and meet at one point, and this point is called focus, principal focus. So here the principal focus is just this side of the mirror, and in this, in convex one, the rays which are falling on the mirror, they diverge. They diverge. Okay, these rays they converge. That is why this mirror is called converging mirror. This in this the rays diverge. That is why it is called diverging mirror. Okay, but you see this is these rays. It seems they are coming from the back of the mirror. Okay, at some point, and this is what focus of this convex mirror. Okay, so this is, I told you about converging mirror and the diverging mirror. Now we are going to discuss the images formed by converging and diverging mirrors. Student, I told you already about the plane mirror. Now concave mirror. You are not supposed to draw the ray diagram, only at what position, what kind of image is formed. It is given in the table 16.1. 16.1 table. Okay, when the object is when the object is between F and P, the position is what? When the object is F and P. Okay, what kind of images is going to be formed? It is always virtual. Okay, it is always virtual. When the object is placed, between F and P, this is the placing, and the image will always form virtual. Okay, second is when the image is formed virtual, when the object is between F and P, real for, and in any other position, like if it is there at F or between C and F or at C, any place, then it would be only when it is between F and P, it is virtual, and if it lie at F or between F and C and at C, then the image is always real. Okay. Acha, erect when the, I told you when the image is virtual, it always what? Erect. And size, um, I told you this, between F and P, then the image is virtual. Virtual images are always erect, and at this position, when the object is placed, then it is what kind of image we will get? Magnified. Okay, so between F and P, we get virtual, erect, and magnified image. Now, second, in case of when the object is placed anywhere, we always get like it is at F, at C, between F and C, we are going to get real image. Real images are always inverted. Real images are always inverted. When the image is at F, it is going to be magnified, big. And when it is between F and C, it is also bigger than the object. And when it is at C, it is of same size. Okay? So now you know about the concave mirror, convex mirror. Convex mirror, we will get only one kind of image, whether the object is placed anywhere at any position. Okay? We are going to keep between F and P object. We will get a small but virtual, erect, and smaller than the size. Okay, so whatever is the position, if it is at between F and P, we will get this kind of image. If it is at F, we will get same image. If it is at C, we will get the same image. So children, that's all. This part we will discuss later on. Thank you, children.